1, solving quadratic equations by using the quadratic formula. Our essential question is, how do you use the quadratic formula to solve a quadratic equation? Our first vocab word is standard form for a quadratic. This is actually a review from earlier in the chapter. Ax squared plus bx plus c equals 0 is standard form. What is important is that all of those terms have to be on the same side of your quadratic, so one of the sides has to be equal to 0. The quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac, and it's all divided by 2a. I know the formula looks like a lot of work, but once you get the hang of it, it's not so bad to use. In Chapter 8, we learned how to solve quadratics by factoring, and sometimes we found out that we couldn't factor them, so we called them prime. The quadratic formula is something that always works to solve a quadratic. So that's why it's really important to have more than one method to solving quadratics. We could also solve quadratic equations by graphing in section 9.1 or 9.3, and we didn't really talk about the meaning. The meaning when you're looking at a graph, the solutions to a quadratic, because they are x equals, they are the x-intercepts. So it's where your parabola crosses the x-axis. Those are the solutions to the quadratic. So again, they can be found by factoring, by graphing, or by using the quadratic formula. The formula always works. Okay, now, as an example, solve using the quadratic formula. Round your answers to the nearest 10th. Our first example is x squared minus 5x plus 6 equals 0. So I'm going to substitute A equals 1.
This is 6801, this is Kilgore 6801.
B equals -5, and C equals 6 into the quadratic formula. So x equals the opposite of b. The opposite of -5 is +5, plus or minus the square root of b squared, which is -5 squared, minus 4 times a, which is 1, times c, which is 6. And this is all divided by 2 times a, which is 1. To simplify the quadratic formula, you need to start out by working with what's under the square root. You need to get that down to one number before you take the square root of it. Negative 5 squared is 25, and then I treat the minus 4 as a negative 4. So negative 4 times 1 times 6 would be negative 24. Then 25 minus 24 would be 1. So 5 plus or minus the square root of 1 divided by 2, and the square root of 1 is 1. So 5 plus or minus 1 divided by 2. Now that plus or minus sign gives us two separate solutions. One of them is going to have the plus, 5 plus 1 divided by 2, or 6 divided by 2 equals 3. The other one is going to have the minus. 5 minus 1 divided by 2, which would be 4 divided by 2, or 2. So our two solutions are x equals 3 and x equals 2. So those are the places where this quadratic crosses the x-axis. So if we wanted to solve by graphing, we could, and we would see that that's where it crosses the x-axis. We could also have solved this problem by factoring. So by factoring this, like in chapter 8, we would start with x times x, and then we would move over to this positive 6, noticing that there's a minus on the 5x as the middle term, so we recognize that we would need two negatives. Negative 2 times negative 3 is positive 6, and if I check by foiling, first outside, inside, last, I would see that it is correct. Negative 2x plus negative 3x give me my middle term of negative 5x. Then remember, because it's equal to 0, we had to solve the zero product property. If x minus 2 equals 0, x would have to equal 2. And if x minus 3 equals 0, x would have to equal 3. So you can see that on this problem, factoring would take a lot less time than the quadratic formula. So factoring may be the choice that you would make if this problem was on your test. Our next example. Our quadratic equation is not in standard form yet. So we're going to have to take this 12 and move it over so that it's on the same side as the other two terms. That will make it a negative 12. So it's like we're subtracting 12 on both sides. Now I can find my values for A. A is 1, B is negative 4, and C is negative 12. And plug them in the quadratic formula. The opposite of B would be positive 4 plus or minus the square root, negative 4 squared minus 4 times A times C. All divided by 2 times A. Simplifying under the root. Negative 4 squared is 16. Negative 4 times 1 times negative 12 gives me positive 48. So underneath the root, 16 plus 48 is 64. So the square root of 64 is 8. So now we have 4 plus or minus 8 divided by 2. Split it into 2. 4 plus 8 divided by 2, or 12 divided by 2 is 6. 4 minus 8 divided by 2 is negative 4 divided by 2, or negative 2. So our two solutions for our quadratic are x equals 6 and x equals negative 2. If this problem was on your test, again, I think maybe you would rather factor this. Factoring this problem, we would use x minus 6 and x plus 2 equals 0. If you FOILed it, you would see that it is correct. And then our zeros would be positive 6 and negative 2. So if you're good at factoring, please remember that that's an option for your quadratics. If factoring does not work, however, the quadratic formula always does. Our last example, I'm going to move both of these terms over to the left-hand side, so I will need to subtract both of them. A equals 3, B equals -2, and C equals -9. A common mistake with your quadratic when you're plugging everything in, the opposite of B would be +2. Squaring -2, it's a common mistake to forget the parentheses around that number. When you square something, it's always going to end up being a positive result. And we've got -4 times A times C. All divided by 2 times A, and on this problem you notice that A is 3. So for the first time, we have a denominator that is not 2. So that's another mistake that's pretty common to make. So it's not that the denominator is always 2, it's 2 times A. Simplifying under the square root, -2 squared is +4. Multiplying -4 times 3 times 9 is 108. So this example does not have a perfect square under the square root. We have 112. So I am going to use a calculator and I am going to round that to the nearest tenth. So rounding it to the nearest tenth, I get 10.6. So 2 plus 10.6 divided by 6, and 2 minus 10.6 divided by 6. So I have 12.6 divided by 6 and -8.6 divided by 6. These are going to be approximate answers because of the rounding. So the first answer is going to be approximately 2.1, and the second is going to be approximately -1.4 for our two solutions. This problem would be one that you would not want to factor. You would want to use the quadratic formula for sure. You can now write your summary. And we did 6 homework problems for this section, page 562, number 1 through 6. If you're able to factor, that's okay, you may factor. Otherwise, show all of your steps and use the quadratic formula. Be careful.